Okay, last one. Are you ready? So this question is specifically asking us to use the second derivative test. So this is here because we want to find the extrema of a function. And I'm going to highlight this because this is an important distinction to make. The second derivative test has nothing to do with increasing or concavity or points of inflection or any of that. The second derivative test, very similar to the first derivative test, its goal is to determine where are the maximums and minimums of our function. So I just want that to be really clear before we even start this question, okay? So in order to do this, we need to find our critical numbers and we need to plug them in our second derivative, okay? So this function is a familiar one. We already know what its first derivative is. I think we've worked with it twice now. 12x cubed minus 12x squared minus 12x plus 12. And because we're looking at extrema, because we're looking at critical numbers, we actually do need to set this equal to 0. Okay? Good news is we've already done this. If you remember, we factored out a 12, x squared minus x plus 1. And then we got kind of creative with our factoring. I thought it was fun. I hope you did too. So we had 12. This was x squared, x minus 1, negative 1, x minus 1. Took out that common factor. And then rewrote these two, right? So 12, x minus 1 squared, and x plus 1. Okay, so we got a little creative with it, but hopefully that was fun. And this gives us a set of critical numbers. X is equal to 1 and negative 1, right? Okay, so we've got these critical numbers. We need to kind of put a pause. We'll come right back to them in just a moment. So I'm just going to hang on to them. Before I can do anything with them, I do need to find my second derivative. So relevant to this, I'm going to write my first derivative again. And we're going to take one more derivative here. Okay, so we have f double prime of x. I actually think we did this one too. 36x squared, 24x minus 12. Okay, we don't need to set this equal to 0. We're not looking for potential points of inflection. We're only looking for what do these two extrema look like when, or excuse me, what do these potential extrema, these critical numbers look like when they're plugged into the second derivative. Okay, so the second derivative test has us plug those values in to this second derivative. So let's look at x is equal to, let's go with negative 1 first, okay? So f double prime of negative 1 is 36 times negative 1 squared minus 24 times negative 1 minus 12. And again, we are only interested in, is this a positive or a negative value? Well, this is positive, negative. Those two are definitely larger. So this is greater than 0. Okay? If you remember, this is a backwards rule. So because this second derivative is positive, that actually means we have a relative minimum at x is equal to negative 1. And you can actually plug in f of negative 1 if you'd like. I'll kind of leave that up to you. Okay? The second thing we want to do is check at x is equal to 1. And it's really the same idea. F double prime of 1, we've got 36 times 1 squared minus 24 times 1, 24, minus 12. This is going to be 36 minus 24 minus 12, and we run into a bit of an issue here because we get equal to 0. Now, this is inconclusive, or I kind of, another way to say it is the second derivative test fails. It doesn't tell us anything in this case. Does that mean you just throw your pen at the wall and you walk away? No, usually what this means is you just take a step back and you actually apply the first derivative test. Okay, so we want to see what happens on either side of this critical number to the first derivative. Okay, so because it fails, we're going to apply first derivative test. So we're looking at if x is equal to 1, that's our boundary right here. So we're looking at values to either side of it. Our only other critical number was -1, so if we pick something like x is equal to 0 here, that works, and x is equal to 2 here, that works, right? Remember, you want to stay within your kind of boundary numbers that you've got. Okay, so if we say, what's f prime of 0? Well, we have f prime. It's all the way back up here. That would be 12, almost there, 12, right? That's a positive value, which means we're increasing, right? Over here, if we plugged in 2, so f prime of 2, and again, I'm going to go back to the factored version, so that's positive because it's squared, also positive, which means that this is going to be greater than 0 also, which means it's still increasing, and it means that x is equal to 1 is neither a maximum or a minimum. And you can always check this using the graph to kind of verify and make sure your answer worked out. Okay? That's all for this week. You'll hear from me next week.